Hi guys! In this week's question, we want to find the range of values of an unknown p when two graphs meet. Recall that when two graphs meet, they share the same x and y coordinates at the point of intersection. Looking at the equation of our two graphs, and keeping in mind that both x and y values for both graphs are the same at the points of intersection, we can substitute y equals x plus 4 into the equation y squared plus x plus p squared equals 8. By expanding and simplifying, we observe that we end up with a quadratic equation in x. Recall that in order to solve quadratic questions, one side of the equation must equal to 0. Hence, we subtract 8 from both sides to make the right-hand side of the equation 0. Corresponding our equation with the general formula of the quadratic equation, we observe that a is equal to 2, b is equal to 8 plus 2p, and c is equal to 8 plus 2p squared. In order to find the solution for p, we will need to make use of the discriminant d equal to b squared minus 4ac. Since we want the values of p such that the graphs will meet, we want the discriminant to be greater than or equal to 0. By substituting the respective coefficients into the formula for discriminant and simplifying, we end up with 32p minus 4p squared. We can factorize this expression by taking out the common factor 4p. Since the coefficient of p squared is -4, the quadratic curve is a -1. We do a sketch to visualize the curve, and find the x-intercepts by letting 4p times 8 minus p be equal to 0. Since we want the discriminant to be greater than or equal to 0, we shade or highlight the portion of the curve that is greater than or equal to 0. Thus, our range of value of p is from 0 to 8 inclusive, or we can say that p is between 0 and 8 inclusive. Want to solve more problems? Keep a lookout on our Instagram page at Crecurate for a new question every Friday. See you next week.